this video, we're going to look at the continuous random variables. But first we want to look at table A2. I mentioned this in the last video. Table A2 is our cumulative normal distribution table. This is the one where we have standardized our values into z-scores. So my 0 is in the center because that's my mean. And then we're using these values to look up the probabilities, the probability that a certain value happens. So when we're looking at table A2, you'll notice that you have here negative z-scores, and on the next part of the table you have positive z-scores. Well, the thing about z-scores is with this cumulative normal distribution, the area is always going to be to the left of the z-score. So here's my positive z, we're talking about this area here. Or up here, we're talking about the area to the left. So anytime that we look up a value on our table, it's going to be that area to the left, not to the right or anything, and not exactly that value. When we have a probability for z-scores, it's very difficult to get that exact value. Usually we look at strictly less than or greater than. So let's look at an example. And again, values in the table are given are to the left of our z-score. So we're looking at whatever area is there. So we want to find the area under the standard normal curve to the left of z equals 0.74. So this is looking at the probability that z is less than 0.74. When using the table, since this is a positive, I would go to the positive z-scores. I would go to 0.7, which is here. And then my last digit, the hundredths digit, is here along the top, and I would look at that column. Well, here, where those two things intersect, is our probability to the left. So it'd be 0.7704. So the big thing to remember is that here are your ones position and your tenths position. Your hundredths is along the top row there. And you're always looking for that intersection. So let's look at find the area under the standard normal curve to the left of z equals negative 2.16. So we're still wanting to the left, so I'm going to have z is less than negative 2.16. Now you may be trying to remember this symbol, is this a less than, is this a greater than? So let's come back over to the top a little bit here. This symbol is for less than, and it's going to be the area to the left. Area left. It kind of looks like an L. So L, L, and L. Now, this one is our greater than, and it's going to be the area to the right. So area to the right. And you'll kind of notice that whichever direction this is pointing, that's the direction that we're looking at for our area. Okay? So let's go back to the probability that z is less than a negative 2.16. That is the area to the left, which is what our table shows. So since this is a negative, I'm going to stay on the negative side. I'm going to go to 2.1, which is this row right here. And then we have a 6 in the hundredths position. So that's this column. And I look at where they intersect. Right here, 0.0154. So the probability that z is less than or to the left of negative 2.16 is going to be 0.0154. Remember, you're always looking for that intersection when you're looking at this table. So now we want to look at what happens whenever we want to the right of a z-score. Well, our table only gives us to the left. There's a couple of different methods that we can use. The first one, anytime that we want a greater than or to the right, recall that this entire area here, that's shaded and not shaded, must add up to 1. So if I want the right, I do not want the left, so I'm going to do a 1 minus. And I look up the 1 minus the probability that z is less than a 0.53. Because we know how to look up to the left the less than. So 0.53, so 0.5 is here on this row. The 3 is here. So I'm going to do 1 minus 0.7019, which is going to give me 0.2981. This is one thing, or one method we can use to look up to the right. Recall that the graph is symmetric, okay? So if I'm looking at this normal curve, and I'm looking here, and I want to the right of a 0.53. 0.53. Well, that's this area here, correct? Well, the opposite of that, symmetrically, would be here, at the negative 0.53. So anytime that you want to the right, or greater than, you can do 1 minus, or you can look up the opposite sign. So if I look up a negative 0.53, here's 0.5, here's my 3 column, I still get 0.2981. Either way, you will come up with the same value. You just have to remember which side you're looking up. Now another type that we might want to look at is if it lies between two z-values. So let's look at the curve first of all. And I highly recommend you drawing the curve every time. Here's 0. We want the area that lies between z is equal to a negative 1.28. So here's a negative 1.28. And z is equal to a positive 1.36. So here's a positive 1.36. We want this area in between. Well, our tables definitely do not give us the area in between. A couple of things that we can do though. Notice if I look at the area to the left of 1.36, that includes this area. And if I look at the area to the left of negative 1.28, that's this area over here, I want this area here. I want their difference. So what I'm actually looking for when I do the probability of a negative 1.28 less than z less than a positive 1.36, you'll notice that I have the z sandwiched between, because I want between, and I have my smaller number on the left side and my larger number on the right side. Well, the way I can look at this is if I take the area here minus the area here. So that's going to be the probability that z is less than 1.36 minus the probability that z is less than a negative 1.28. So let's look for the 1.36. I have to go to the positive side, 1.3. And notice I don't have the values across the top, but that's okay because this is 0, 1, 2, 3, 4, 5, and 6 here. So the area to the left of 1.36 is going to be 0.9131. I'm going to subtract, and then I'm going to look for the area to the left of negative 1.28? Well, here's a negative 1.2. 0, 1, 2, 3, 4, 5, 6, 7, 8. So that's a 0.1003. And I want to subtract these two. When I subtract these two, it's going to be 0.8128. So the probability that z is in between a negative 1.28 and a positive 1.36 is going to be 0.8128. Now, maybe you forget which order to subtract. Maybe you try taking this value minus this value. Remember, probabilities must be between 0 and 1. I cannot end up with a negative value. So if you accidentally subtract and get a negative value, you might want to just rewrite the order that you're looking at. When you are looking at between two values, you're going to need to do some subtraction. Subtract with the probabilities. Do not subtract these z-scores and try to find a single z-score. We want to find the difference between their probabilities, not between their z's. One last method that I want to show you is I want to find the z-score for which the area to the left of it is 0.13. Well, here we don't have the actual z-score. We have the area. So here's my 0. And I know that it's going to be 0.13, so that's partly over here in this smaller section. This is 0.13. I want the z that corresponds with it. So what I'm going to do is I don't have the z, I have the probability. The probabilities, recall, are in the center of my table. So what we have to do is we have to look in the center of my table for that value, 0.13. 0.13 is my probability. So if I'm coming down here through here, 0.0, 0.1, okay, here's 1, 1, and 1, 3. Here's where it changes from 0.13 something to 0.12 something. So I know it's in between here. I can't find 0.13 exactly. So whenever I find this right here, what I need to do is I need to say, which one of these is closer to exactly 0.13? And if I want to, I can add the two zeros. Well, looking at this one, 0.13 minus a 0.1292 is going to give me a 0.0008. So there's a difference of an 8 here. And then looking at the other side of it, let me come down here so you can see this a little bit better. 0.1314 minus a 0.13. That's going to give me a 0.0014. This is 14 points away. This one's only 8 points away. This one is the closer one. Okay? Again, we can't get exactly. So the z that corresponds to this, I have to follow it over, negative 1.1, and then I have to follow it up to get my hundredths position. And I got to keep following it up. Let me get it here. There we go. 3. So it's going to be negative 1.13 is the z that corresponds to a probability of 0.13. Now, it is very coincidental that these are 0.13 and 0.13. That does not happen very much of the time. So be careful. Don't assume that just because this is 0.13, this one's going to be 0.13. You have to look up the probability in the center of the table. So I'd like for you to start working on several of these, looking for areas to the left, looking for areas to the right of your z-score. Begin trying to draw those symbols. Try to draw the distribution every time. And when you do, you put 0 in the center So I don't want to put a negative value over here or a positive value over here. I also want to look at, well, if this is half of it, if my probability is only 0.42, I don't want to put it over here. So start looking at aspects of that. Let me know if you have any questions.